Alrighty guys, so I gave you this average atomic mass practice sheet. Hopefully you guys feel like you're doing really well with it. It is not that bad, I promise you, okay? I feel like I literally just gave you 5 problems on this sheet because I feel like once you do the 5 problems, you're like, I have this. But I cannot stress this enough to you. Memorize this process. Have it to memory of how you're going to get it. Okay? So, without further ado, let's get rolling. Let's work an answer key. Alright, so we have neodymium there. Neodymium. So we have 1, 2, 3, 4, 5, 6, 7 isotopes. I did this on purpose because I wanted you to get to actually see how this would work with a bunch of isotopes. So I need you to work with this and see. You guys can do this. Neodymium, if you're looking on your periodic table, is right here at number 60. So right there is neodymium. Neodymium is very useful in if you like to play music. They use neodymium magnets in the pickups within instruments. Okay, so first step. You cannot do the math that we're going to do with a percentage. We have to have the decimal of the percent, and that's where we look and we divide every one of these by 100. I'm talking the percentages only, okay? Not that isotope, not that mass number. And we will get the decimal for this percentage, okay? If you need to, type it in a calculator. I'm not going to. I would get 0.272, get 0.122, 0.238, 0.083, 0.172, 0.057, and 0.056. Now we have those numbers to where we can actually do the math part that we need to do. I know this looks very, very long and pointless, but I am going to write it out just in case you need it. So in this, I'm going to start here. I'm literally going to work my way down. Oh, so I have isotope 142 times 0.272 plus isotope 143 times 0.122, isotope 144 times 0.238 plus isotope 145 times 0.083 plus isotope 146 times 0.172 plus isotope 148 times 0.057 plus isotope 150, neodymium 150 times 0.056. Alright, when I do this, I literally am going to type it in like crazy in this calculator. I'm going to see if I can darken this so you guys can see it better. Alright, so this is what I'll do. I literally take all that, and I even use my parentheses. Do not be scared to use the parentheses. Parentheses 142 times 0.272 in parentheses plus 143 times 0.122 plus 144 times 0.238 plus 145 times 0.083 plus 146 times 0.172 in parentheses plus 148 times 0.057 in parentheses plus 150 times 0.056 in parentheses hit it all together, and the number that I get for the average atomic mass is 144.325. And remember our units you can put here. I already showed you guys a little bit on our mole conversions. That's why I like to use the units that I'm going to use here of grams per mole. If you put AMU, if you put those atomic mass units, you are still correct, and I am not going to take that out on you at all. You guys are totally fine. Now, I do have a habit, and I love when students do this also, when you box in or circle your final answer. The reason I like that is whenever I'm grading your quiz, I automatically know where to jump to see your answer, so if you got it right, I don't have to dig, and it saves me time, because you guys are just wonderful people. Now, this one doesn't work out quite as nice as others will. Whenever I look at you and I told you which one of these isotopes would this be closest to, look, we don't have a real big, huge running majority for the isotope of neodymium, so we really can't say that this is going to be, this should be really close to a certain number. But what we can do is we can look on our periodic table here at neodymium and find out that they have the average atomic mass is 144.24, and we have 144.325. It's really close, and it's good. The reason theirs is different than ours is they have the true, actual, real mass that they're using for those isotopes. And for our purpose, we're just going to use the mass number, the isotope that comes with it. That's just if you were wondering where the subtle differences are coming from. Now, boron. Let's look here at boron. This is going to be the same thing, but before we get started with boron here at number 2, you should be able to look at me and tell me which number boron should be really close to. 80% of boron is boron 11, which is telling you this number should be close to 11. Will it be super close? No, but it should be closer to 11. Alright, sorry. So on this, talking of boron, you can look at me and tell me boron, the average atomic mass for boron should be really close right here to 11. It should be closer to 11 than it is 10, because 80% of boron that exists is boron 11, while boron 10 is almost 20%. So in this, let's work calculation with it. We knew what we did before. This one's shorter, thank the heavens. Divide by 100. Get rid of that percentage to get that to a decimal. I know there's somebody watching this video, I know there's someone that's in class that's not going to heed my warning on this, they're not going to pay attention to this. You're going to use that percentage number and you're going to be wrong. Divide that by 100, so 0.199. Divide 80.1% by 100, so 0.801. This is a good time to mention, I do not like the phrase just move the decimal. We are not just moving the decimal. You cannot just move something in math. There has to be a mathematical property or something that you do to get to that phase. So in this, boron 10 times 0.199 plus boron 11 times 0.801, and I'm literally going to do what I did up there. I'm going to type this in the calculator, try to bring it up here so you guys can see it. Parentheses 10 times 0.199 plus 11 times 0.801 in parentheses, and I get 10.801 grams per mole, or atomic mass units if you want to use those. Those are acceptable. I cannot speak today. So there's number 2. Let's go to number 3 on here. Number 3 is not that bad. We use these isotopes for examples of calculating how many neutrons are in there. So we're going to do the same thing. Divide the percentages by 100. Once you do that, you get 0.7899. We get 0.10 and 0.1101. Do what we've been doing. Just keep rolling with it. 24 for magnesium, 24 times 0.7899 plus 25 times 0.10 plus 26 times 0.1101. That 6 looks like a G. Here we go. Let's fix that. Let's type that in the calculator. So we get 24 times 0.7899 plus 25 times 0.10 plus 26 times 0.1101 equals 24.3202 grams per mole. I should have done this. I apologize. Should have done this with boron too. But let's look here. Here's boron. So 10.81 is the average atomic mass of boron. 10.801. Beautiful. Really, really close on that one. Let's look at magnesium. Magnesium is over here. Magnesium is 24.31. So 24.31, we get 24.3202 grams per mole. That's also really close. So that right there is great indicators. I've done this properly. I've got the right answer. Okay, let's look at chlorine. Here, chlorine. We have 35 and chlorine 37. Divide those by 100. Those percentages, get those decimals of percentage. 0.7578 and 0.2422. Then we're going to do some math. 35 times 0.7578 plus 37 times 0.2422 will equal to, punch this in a calculator, parentheses 35 times 0.7578 in parentheses plus 37 times 0.2422 equals 35.4844 grams per mole. You say, Mr. Hall, that's not as close to 35 as I thought it was going to be. It's almost a half, 35 and a half. Look, though, I know it's isotope 35 is like over 75% of it. Look at that 37. That's chlorine 37, so that number, that larger number, does factor in a little bit, but it is still closer to 35, like it should be. All right? I feel like you guys are rocking and rolling with these. I hope you're doing well. If not, you need to come ask me. Okay, this is something that will come up later on in class. All right, let's look here. Last one, number 5, titanium. We're going to do what we did before. We're going to divide all these by 100. While I'm doing this, what number do you think the average atomic mass of titanium will come close to? Hopefully, you said 48, because titanium 48 literally is 73.72% of titanium. So let's do 0.0825. This is 0.0744. 0.7372. This is 0.0541. This is 0.0518. Okay? So let's do some math here. Let's do 46 times 0.0825 47 times 0.0744 plus 48 times 0.7372 plus 49 times 0.0541 plus 50 times 0.0518. Do some math here. Type this in the calculator again. Hopefully you guys can see this on the calculator. That's my hope whenever I'm working these out. That's why I want you to be able to see this, to know what I punch in the calculator as much as what I'm writing on the paper. Making sure you can punch this in a calculator correctly is important. Alrighty, so we get 47.9183 grams per mole. So 47.9183 grams per mole. Very nice. Let's look on our periodic table, see how that stacks up. We get 47.88 on the periodic table. This one's a little farther off, but still a really close number on that. And then look, I know at first glance you're going to say, that's not close to 48, Mr. Hall. Take a closer look, 47.9. That 47.9 is really close to 48. So on this, if you guys have any questions with this average atomic mass practice sheet I gave you, if you have any questions at all on it, please, next time you see me in class, ask me. Feel free to message me on Remind or even message me on LiveGrades, guys. I'm here to help you.